I'm going to have to tell you right now, we can't predict Game of Thrones. So if you came here expecting that I would tell you how to do that, it's impossible. And frankly, it would be quite offensive to George R.R. Martin to say that we could predict it, because one of the great things about his books is that they're very unpredictable. So sorry about that. Probably it's ruined it for you already. Now, I'm assuming everyone in the audience has either read Game of Thrones and is a great enthusiast, or doesn't really care and just came to hear a lecture. For those who don't know about Game of Thrones, I'm just going to give you a quick rundown of what it is. So this is a series of novels by George R.R. Martin, started in 1996. It's become very popular since 2011, because they started making a TV series of it, which is really big. So far, there have been 5 books. 2 more are anticipated, but we don't know when they're going to appear. And the plots are very intricate. They're very thick books, very complicated plots, lots of characters. And one of the interesting things about them that appeals to people is that major characters are often killed off. And so what's going to happen next is a subject of a lot of speculation. And you'll see stories about this almost every day in the media. So it's a big deal at the moment. Sort of like Harry Potter. Okay. Now, each chapter in the books is told from the perspective of one character. And, yeah, I don't know who... there are several versions of this online. I don't know exactly who came up with this one. I just got it from Google Images. They're told in the third person, but the action takes place from the perspective of one particular character. And so the question I wanted to ask in particular was, can we predict which characters are going to show up next in the next book, The Winds of Winter? And the answer is no. That's pretty much impossible. So what I want to talk about today is prediction in general. Why is this such a hard thing to predict? And why are some things not hard to predict? So for example, recently we had an election, right? And it was sort of unpredictable who would form the government, but everybody could have predicted beforehand that National will get the most votes. That was pretty much obvious. And so why was that easy to predict, but Game of Thrones is hard to predict? And I'm going to try and explain, or give some justification for that. So I just want to talk about different kinds of prediction here. Now, this is one kind of prediction you could have. This was a statement by the Treasury. They said that over the next 4 years, GDP growth was going to be 2.8% on average. Now, what I want to point out about this is just a number. Now, if GDP growth turned out to be, say, 3%, we still think that was a pretty good prediction because they got pretty close. So this prediction doesn't really mean that they're saying GDP growth is going to be exactly 2.8%. So giving an exact number, that's called a point prediction. And other examples are, if I rolled a die, I might say that's going to be a 3, that's my prediction. Or maybe for Game of Thrones, I might say I expect exactly 9 chapters in the next book to be told from the point of view of Tyrion. That's another point prediction. But usually when people make a prediction, what they really mean is an interval of possible values. So here's one from the Australian budget in 2013, and they said they expected GDP growth to be in the range from 1.5% to 3.25%, and there was a 70% probability that this was right. And they got this 70% number in a clever way. They looked at what predictions they made in previous years and figured out how wrong they were, and then used that to give a range of possible values and say how confident they were that those were actually correct. So this is giving an interval of possible values. This is generally better than just giving one value. And so for GDP growth, we might say it will be around 2.8%. We might say a die roll would have a range of possible numbers. It doesn't have to be an interval. We might say Tyrion's point of view chapters might be in a certain range. In this case, a very wide range, which is probably going to be accurate. Now, I want to tell you, just for fun, some ways you can be correct. Now, this is how to make a correct prediction. So there are various ways to do this. One is make sure that people want your prediction to come true. So for this reason, it's really bad to predict the end of the world, Nobody's ever done this correctly. And if you did, people wouldn't be very impressed. They'd probably have more things to worry about than your prediction being right. And another illustration of this is this story about the prophecy of St. Malachi, which was made by St. Malachi in the 1100s, I think, or possibly by somebody who was faking the prophecy in the 1500s. And what he said was he gave a cryptic phrase describing each of the future popes all the way up to the end. And the phrase for the pope who was due to be elected in 1958 was shepherd and sailor. And the story goes, the story isn't true, I think, but it's a great story. This guy, Cardinal Spellman, really wanted to be pope. So he hired a barge, filled it with sheep, and sailed it up and down the Tiber to try and persuade people that he was the right candidate. He didn't end up becoming pope, so in that sense the prophecy didn't come true. Another thing you can do is to manipulate events so that your predictions come true. And these people are mentioned in Charles Mackay's Extraordinary Popular Delusions. And they apparently predicted that people would die and then poisoned them. Another thing you can do, which is much more subtle and clever, is to make a lot of predictions, but only report the correct ones. So we have a good example of this for Game of Thrones. A few weeks ago, it was reported in the media that fans have already predicted the story correctly. So they already know exactly what's going to happen. It's just we don't know which fans made the prediction. So it doesn't help us, but somebody's got it right. And another example is Paul the Octopus, who predicted the outcomes of games in the 2010 Football World Cup. And the reason why that's not very interesting is because there were lots of animals making predictions for the World Cup. There were so many that probably one of them was going to get it right, just by chance. So that's another kind of illustration of this. I'm not blaming the handlers of Paul for this. I'm sure they acted in good faith. And if you apply the statistical tests from any first-year statistics class, you'll see that there's a strong evidence that the octopus is psychic. But the best thing you can do in general to make a prediction is just the kind of thing that Malachi did or Nostradamus did, is just to be vague. You know, don't definitely say anything or make an interval prediction. You know, all these things are good ways of being vague. So if your prediction is vague enough, it will come true. So there's a trade-off between your prediction coming true, which I'm calling accuracy here, and how vague you are, how much uncertainty there is in your prediction. And we want to quantify that uncertainty, and the way to quantify uncertainty is to use probability. So probability is a way of measuring uncertainty, and it's just a number between 0 and 1. And you can think of probability as an extension of logic. So in logic, you have true and false. True is 1 and false is 0. But in probability, you add in other values which indicate how certain you are that something is true. They can be any values in between 0 and 1. So here's an example of how probability works. Let's think about rolling a die. We can get the numbers between 1 and 6 out of that die roll. Now, at one end of the probability scale, we have 0. So that's an event that can't happen, like rolling a 7. You can't do that. That has probability 0. And then we definitely know for certain that the probability will be, the die roll will be something between 1 and 6. So the probability of getting a number between 1 and 6 inclusive is 1, because that's absolutely certain to happen. But then in between you have all the other things which could happen. So for example, the probability of getting either a 1, a 2, or a 3 is 1/2, 0.5, because that's an even money bet. And exactly half of die rolls you're going to get one of those values in the long run. So instead of saying a point prediction like we'll roll a 3, you could say the probability of rolling a 3 is 1/6. That puts a number on your uncertainty. And the way I want to think of interpreting that is it would be a fair bet, as the odds of a fair bet. I'm not entirely sure what the odds are for this one. I can't remember, but we'll just say the probability is 1/6. And even better than that, you can give the probability of every possible outcome using a probability distribution. So these bars show the probability of getting each number between 1 and 6, and that completely describes what you think is going to happen when you roll a die. in this case, that all the possible numbers are equally likely. So that's a really nice kind of prediction, a probability distribution. A bookmaker would call this, giving probabilities like this, handicapping. So if you've heard that term before, that's what it's called in bookmaking. Oh, and I should say, the next talk in this series is called What If a New Zealander Won the Nobel Prize for Literature? And the speaker is going to give the probability that that would happen in the next so many years. So that's also an example of this. Now, this is the kind of prediction that I wanted to make for Game of Thrones. So this is part of the output. This is the distribution you get for the number of point of view chapters of one of the characters. In this case, it's Sansa. Now, it seems like there's a huge spike at 0. So you might think, well, I guess this means she's going to have 0 point of view chapters. That's a bit misleading, because actually that only goes up to, well, it's below 0.4. So the probability of having more than 0 is actually bigger than that.
What are these probabilities for?
For the probabilities of the different numbers of point of view chapters that Sansa Stark could have in the next book. Yeah. Now, the way I would want to summarize this distribution is to say, well, it's probably going to be either 0 or somewhere between 3 and 7. And that's a really vague prediction. So it could be right. But it's not very interesting. Now, I want to go on a bit of a digression. I could jump right now to the end of the talk, but I want to talk a bit about probability and uncertainty in more generality. So we have probability, which we're using to measure uncertainty. But you might ask, how did I get these probabilities? You know, how certain am I that these are the right probabilities? And the answer is not very certain at all. So we don't just have uncertainty, we have uncertainty about uncertainty. And then if we had some way of measuring that, maybe with probability, we'd have uncertainty about those probabilities. And we just get an infinite tower going on and on. So I just want to look at the second step of that tower and ask, how can we measure how uncertain we are about our uncertainty? Because this is quite an interesting question. So the idea is, in the first step, we're using probability to describe how uncertain we are. But maybe we can look at the second step and say, what comes after that? How do we describe uncertainty about uncertainty? Now, these are two people who had something to say about this question. On the left, you have the famous economist John Maynard Keynes. Now, Keynes studied probability when he was younger, and in 1921, he published a treatise on probability. And the book isn't very famous. Well, it's famous, but it's not read very much now, because Keynes didn't really come up with any theories, but he did have some ideas about what may be wrong. And he said that maybe probability isn't the right thing to describe your uncertainty in every case. So one of his key ideas was that there might be some other kind of probability or some other kind of measure of uncertainty which isn't even a number, which is what people actually use to describe their uncertainty when they're thinking. But he didn't give any theory behind this. It was just an idea. But it's probably a really good idea. And so that was Keynes. And then on the right, this guy is a statistician who nobody nowadays has heard of, but in his lifetime he was really famous. His name was Wilhelm Lexis, and he was active in the 1880s. And Lexis founded a school of statistics which persisted until the 1920s or so, with various followers of his. But in the end it petered out. And one of the things that he was really interested in was whether you could measure how accurate a probability that you were using to quantify uncertainty was. So he was very interested in uncertainty about uncertainty and using probability to measure that uncertainty. And so Lexis developed some methods, but they're not widely used because, unfortunately, they only really applied to one very special case. And they didn't have very wide applicability, so they didn't really catch on. And in the end, other people started doing more practical things, and Lexis's ideas were gradually forgotten, mostly. But he was one of the few people who actually thought about this, so it's kind of interesting to mention him. So those are two ways in which you can be uncertain about probability. Is it the right thing to use, and how can you quantify how wrong your probabilities are. But there are other things that are uncertain about predicting the future. We have the problem of extrapolation. So this problem is that when you try and predict the future, the only thing you have to go on is what's happened in the past. And if something has never happened before, there's no possible way that you could guess that it was going to happen next. Now, one illustration of this is due to the philosopher Nelson Goodman. This is a simplified version, or a slightly different version than what he did, but it will suffice for the purposes of illustration. It's called the Grue paradox. Now, Goodman defined a new color, Grue, to mean green before 2024 and blue afterwards. And the point is that you can't distinguish between something which is Grue and something which is green, because they look the same to us, right? Because it's not 2024 yet. For posterity, this is being filmed in 2014. Now, you might say that's ridiculous. We know that things don't spontaneously change color, but why do we know that? Because it's never happened before. This is a philosophical problem, you see. Now, the good thing about this paradox, though, is that it's not that long until 2024. So we're going to know pretty soon whether Goodman was correct. Now, the reason why this is called the new riddle of induction is because it's about induction, which is a thing that philosophers like to talk about. So there are two kinds of reasoning, and we're getting onto really thorny philosophical problems now that are kind of important to philosophers and also to everyday life, actually. So there are two kinds of reasoning. There's deduction, which is reasoning from causes to effects, like you do in mathematics when you say x equals 2, therefore x plus 1 equals 3. But then another kind of reasoning which we use a lot in everyday life is reasoning from effects to causes. So for example, if you think about Sherlock Holmes, if he finds some feathers at the crime scene and deduces, using his powers of deduction, that the murderer owns a parrot, that's not actually deduction, even though that's what he's famous for. It's induction, because he sees the feathers and he works out that the murderer must have a parrot, but he's using induction because he has seen the effect of owning a parrot, feathers. But he hasn't seen the cause, so he's going backwards. And you can't be certain about something that you conclude from induction. That's the problem. So even though Holmes is always right, that's just for artistic effect. In real life, anything you conclude from inductive reasoning is doubtful, uncertain. And that leads to the problem of induction, which is famous. It was, I think, famously expressed by Hume, the philosopher. I think it was Hume. It might have been somebody else who was... no, I'm pretty sure it was Hume. It might have been Locke or somebody like that. Which is, can induction lead to knowledge at all? And what is knowledge anyway? And is the kind of knowledge that you get from induction different from the kind of knowledge you get from deduction? And these are all very difficult problems. But this particular one is the problem of induction. So, in a very broad sense, statistics is a subject which attempts to do inductive reasoning, and it does it using a framework of probability. So it's using numbers to try and describe inductive reasoning. And this picture shows how statistics works. You start with a data set, so that's just some information. It could be numbers, it could be anything, which is given to you. And then you try and figure out the cause. So the model, you call it a model. You try and write down some equations that describe something that could have caused that data set to appear. So this is reasoning from effects to causes. You come up with your model, and the model has some randomness, so there's some uncertainty built into there. And then that model can generate other data sets, and you use that fact to try and figure out how much uncertainty there is. So the whole point of statistics is that there's some randomness in this model. So it doesn't always generate the same data set, but you choose it in such a way that it's quite likely to have generated the one that you started with. And going backwards along this dotted arrow, that's where induction happens. So just summarizing that little discussion, This is the procedure you go through when you do statistics. You start with a data set. You find a model which could have generated your data set, which is basically just a list of equations or something. And then you measure your uncertainty by looking at what your model could have generated in other situations if some randomness had gone a different way. And this is great, but remember, induction happens when you go from the data to the model. So there's a question, how do you know whether you have the correct model? And the answer is, you can't really know that. You have this uncertainty about whether you have the correct model uncertainty. And you can't really measure that. Now I can explain why the election was easy to predict, but Game of Thrones is very hard to predict. So why was it easy to predict the election? Well, the reason why is because we understand really well what model we should use for an opinion poll. So we understand how opinion polls work. We understand the statistics behind it and the probability models that we should use. And we understand very well from experience how those can go wrong. So opinion polls have gone wrong in the past, and people have figured out all the things that can go wrong and how to correct for them. So they're not perfect, but we have a really good model for that, and we can be pretty certain that we get the right answer from opinion polls. But for Game of Thrones, it's something we've never seen before. We only get one try at it, and we have no idea what the right model might be for describing our uncertainty about Game of Thrones. It's just a guess. So for that reason, it's really hard to predict it. That explains that, I hope. So to summarize that discussion, if we look at the second turtle in the pile, remember we have probability, and then we're describing our uncertainty about probability. There are various kinds of uncertainty. We have the fact that we don't know whether we should be using probability. We don't know how to describe how accurate our probabilities are. And then there's the problem that we can't use the past as an infallible guide to the future, the problem of induction. And then there's the problem that we have model uncertainty. We don't know whether we chose the right model. So there are all these different kinds of uncertainties, and that just makes life a bit harder, so we generally ignore them. I like this slide very much because it's one of those things that if you saw it at the beginning of the talk, you'd have been like, what? I showed it to a friend of mine, and he said, not enough turtles. But now it makes perfect sense. So here's a schematic picture of how statistics works for prediction. In step one, you start with a data set. Here we've started with a bunch of points in the XY plane, these red points. And then in step two, you choose a model which describes this data set. So here we've chosen, it looks like the points roughly follow a straight line with some random fluctuation, which we choose to treat as random. So we put a straight line there. And then in step three, we extend that line to make a prediction into the future in this case. So that's those dots there, and that red dot is our prediction. It's just a picture, you know, it's not meant to be a proper statistical model. And then in step four, somehow we use our knowledge of randomness and the power of statistics to work out how accurate that prediction might be. So that red line there is meant to be sort of indicating an interval of possible values that we think are sensible predictions around our point prediction, which is the red dot. So that's the idea of how to make a prediction using statistics. And that's what I tried to do for Game of Thrones. It's exactly the same 4 steps, except the steps look a bit different, but it's the same, conceptually, exactly the same idea. So what I started with was some data, and I chose to use this data which describes all the characters and the number of point of view chapters that they had. So that's that table there. It's a very small table. It only has 120 entries, so there isn't that much information there. I'll talk about that in a minute because it's a big problem. Then in step 2, I found some equations which I felt...
We can't read any of that. Can you tell us what the column headings are?
Oh, don't worry about that. It's not important. It's just a picture of the data. I can zoom in if you like. Spoil.
Just tell me, just what to the foot of the 4, 5 columns.
Oh, those are the names of the books. The columns represent the books, and the rows represent the characters. Yeah.
And the number in the row column?
That's the number of point of view chapters that that character had in the corresponding book. Yep. Okay. Yeah, but I don't want to go into details. That's fine, though. So that's what the data was that I chose to use. And I'll explain in a minute why this is probably a bad idea. Then I wrote down some equations. That's my model that describes how the data might have arisen with some randomness. Then I put that into a computer and fitted the model using a computer, and then I got some predictions out of it and made some graphs. And that's exactly the same as these 4 steps in this picture, just in this Game of Thrones context. So the question then, after you get the predictions, you want to ask, are they any good? And they would be good if the model was correct. But the model is clearly not correct in this case. How do we know? Well, because there are lots of fans trying to predict Game of Thrones, and they're much more into it than I am, although I do like the books. So they basically said, well, this is clearly wrong because of various things. Like, for example, the model predicts that, or the model is set up in such a way that a character who's been in there for longer is more likely to die, which might not be true. So there are various problems with the model. So we know the model is definitely not correct, and we also know that we've used a very limited amount of data. So yeah, the model will make some, it's already clear that some of the model's predictions are wrong. And the model is only a very rough description, and it's not going to be accurate. But that might be okay for me, because the saving clause is that there's no obvious way to evaluate the model's predictions anyway. The problem is, we're only going to get one version of the Winds of Winter. So this book is only going to be published once. And when an event only happens once, it's not clear what probability even means. Now, if you think about rolling a die, if you say the probability of getting a 3 is 1/6, that means you could roll the die 600 times, count how many 3s you got. If you got about 100, then you know that you're probably right about your probability. But when you give a probability for an event that only happens once, it's not too clear how to interpret that. My friend David Sickmiller illustrated this by doing an experiment. He went around challenging people to play a game with him. And what they had to do was, he had a 10-sided die. They could pay him $2, and then they got to roll the die, and if they got a 1, then he would give them $20. Now, this game, according to a statistician, is equivalent to David just giving the person 20 cents, because that's how much you expect to win on average. But many people, including me, didn't want to play the game. And the reason why is because I thought, well, I'm probably going to lose $2, so why would I want to do that? I mean, I might win 20, but, you know, it's a bit of a risk. It seems that we don't really think about maybe probabilities in quite the way that we do in mathematics. Yeah, so it's not clear. If something is only going to happen once, probability and expectation might not mean the same thing as they seem to mean in statistics. So it's not clear how we can evaluate the model, although I have some ideas, and I still think it's going to be wrong, so it's okay. So then we can ask the question, is there a better approach for predicting Game of Thrones? How could we actually predict it? If we didn't want to just build this tiny statistical model and we really wanted to be accurate, how would we do it? Well, if we wanted to use mathematics, we could probably grab a lot of information from the text of the books and all the news stories that have been coming out and the announcements that George R.R. Martin has made, sample chapters, you know, there's a lot of information out there. And if we collected all that together, we'd have a big amount of data. Maybe we could get a prediction out of that. And there were these 3 Danish, I think they're from Denmark, I'm not sure, but there were these 3 students who did a project earlier in 2014 on this. And they used textual analysis. They actually looked at the texts and looked at the relationships between characters. They didn't come up, I think, with any firm predictions, but they were going in the right direction. So for these students doing their project, they probably didn't have enough time to really do it in detail. But if you really wanted to do it, you could probably take this approach, this big data approach. And that's the that's the thing that might predict better. And the general trend nowadays is that big data is good for making predictions, provided you can really get into it and figure out what is important in there, in your massive data. And statistical models are maybe getting a bit old-fashioned, and maybe traditional statistics is gradually being overtaken by this these new ideas coming from computer science, which often give you better predictions. So I'm almost finished. I promised in the abstract that I would say why we should predict things. So why am I even trying to predict Game of Thrones if it's impossible, as I've repeatedly said? And why would I care about that problem? Well, I care about it because I was interested to know what would happen next in the books, but why would I want to do this statistical prediction? And in general, why should we predict things? Well, Karl Popper, who actually worked here for 9 years, he's famous for his falsificationist theory, which says the only way we can know if a prediction is if a theory, is incorrect, is to make a prediction from it and see if it's wrong. You can never know if it's correct because the wrong theory could still predict correctly, but you can certainly tell whether the theory is incorrect if it made an incorrect prediction. Popper is really famous. He's one of the most famous academics of the 20th century. There's a hall of residence named after him somewhere on the edge of campus. He worked here for 9 years, as I said, and he had a bit of a battle with the administration because they wouldn't let him use university notepaper to do his research. And then after that, he moved to America. So physicists are totally on board with this. They like to predict things. In fact, they spent 7.5 billion euros building the Large Hadron Collider purely to test the predictions of their theories. Because in physics, it's absolutely important that your theories be verified by experiment, because you need to know whether they predict correctly, because you're trying to find out about nature. And if your theories are wrong, then you're not describing the natural world. So they care a lot about prediction. But in some subjects, people don't seem to care very much about prediction, or not all people seem to care about prediction. And some of these subjects are important because they have an impact on people's lives. Like, for example, economics. So in 2008, November, the Queen toured the London School of Economics. And after the tour, they asked her if she had any questions, and she basically said, I'm paraphrasing, she didn't say it this way, but she basically said, if you're so smart, how come you didn't predict this financial crisis that's happening? This was in 2008. And they couldn't answer her question. They had to think about it and write her a letter several weeks later. It seems like the models of economics aren't necessarily very good at predicting. Not always anyway, and not all economists really care. And that would be okay if they were just using them as toy models to experiment with things. But a lot of economists actually go around advising governments what they should do, and this has an impact on people's lives. And so the fact that some of these people don't care about prediction is a really serious problem in everyday life. And we're about to have a discussion, so we should maybe discuss that. So that's the end of my talk. I just want to say, just give an advert for next week's talk. Oh, I'm sorry, 2 weeks' time, there's another talk. What if a New Zealand writer won the Nobel Prize for Literature? As I said earlier in the talk, this person is also going to talk about odds and handicapping the various New Zealand authors to see which one might win the Nobel Prize, what the probability of that is. So presumably it will be similar to this one in some ways. That's the end of my talk. I'm happy to show you the Game of Thrones predictions, but as I said, they're not super interesting. Thank you very much for listening.